Hello, and welcome back to OLLI's 2024 at the U Speaker Series. I'm Laura Peterson. This at the U series comes to you from the Osher Lifelong Learning Institute at the University of Minnesota. OLLI is a learning community for people 50 and over who are curious, lifelong learners. We offer hundreds of non-credit courses a year, plus other ways to get involved, like special interest groups and volunteer opportunities. I want to extend a warm welcome to our OLLI members who are on this webinar, as well as our guests, and a thank you to our sponsors, AARP Minnesota and the University of Minnesota Alumni Association. We acknowledge that the University of Minnesota Twin Cities is built within the traditional homelands of the Dakota people. It's important to acknowledge the peoples on whose land we live, learn, and work as we seek to improve and strengthen our relations with our tribal nations. Today's presentation is titled Diabetes, Obesity, and the Next Generation Drugs Shaping Our Future, with Dr. David Bernlohr and Dr. Lisa Chow. Dr. David Bernlohr is a Distinguished McKnight Professor and head of the Department of Biochemistry, Molecular Biology, and Biophysics. He received his PhD from the University of Illinois, and his research focuses on metabolic relationships between obesity, diabetes, cancer, and aging. Dr. Lisa Chow is a professor and director of the Division of Diabetes, Endocrinology, and Metabolism. She is a graduate of the University of Minnesota Medical School. She is also the Pennock Family Land Grant Chair in Diabetes Research and serves as program director for the Diabetes T32 Research Training Program. Her research focuses on the effects of lifestyle changes on insulin resistance and diabetes. Drs. Bernlohr and Chow, I will turn it over to you.
Good morning.
Good morning, everyone. Thank you for being here. We're excited to have an opportunity to Zoom with you this afternoon and give you a little bit of our thoughts on the major transitions that are happening in our country on diabetes, obesity, and their influence on human health. So we look forward to this, and please ask questions, and we'll be anxious to relay what we can. So we're ready. Let's get started.
So I will say this is a unique presentation because it is a combination of clinician, that's myself, and basic scientist, that's Dr. Bernlohr. So you do get two views of the same issues. So we'll go ahead and get started. Let's stay on this, right?
Oh, goodness. I think I'm already sharing. All right.
All right.
Perfect. I can see that and I can hear you.
Are we all good?
We are all good.
Perfect.
You're gonna have to. Gotta get our pointer going here.
Yeah, just show me, advance the slide.
Yeah, I may have gone to sleep. There we go. We can use the outside ones. Ready?
Okay, that sounds good.
Outside.
All right. So as we know, there is an epidemic of obesity here in the United States. Here is a map from the CDC that shows the obesity rates in 1987. Now, keep in mind that obesity is when your BMI is greater than 30. What you can see here is that the light blue is less than 10% rates of obesity, and the dark blue is about 10 to 14%. So this is where it was in 1987. So you flash forward to 2023, so 35 years later, and you can see that the map's no longer blue. In fact, it's quite orange, and if not brown. And the areas that are green are where the obesity rates are less than 20%, where it is sort of orange to red, it's about 30 to 40%, and where it's sort of the dark brown, such as Oklahoma, Louisiana, it's about 45% to higher. So certainly the obesity in the United States has significantly increased over the last 35 years. When you look at actual numbers, approximately 42% of the US adults now have obesity, and it's not just adults. About 20% of US children and adolescents have obesity, and this is extremely expensive. It's thought that when you have obesity, your annual medical cost, so each year, is about an extra $2,000. Now, what this is thought to be due to is primarily environmental factors. Genes do not change very fast. It takes thousands of years to change. So the fact that obesity has increased so much over 35 years is likely due to the environment. And this is thought to be twofold. A, more calorically dense food and more availability of food. And B, less physical activity. Certainly, we are a lot more sedentary now, especially in our jobs, than before. So now I'll turn it over to Dave, who will talk about what exactly is adiposity.
All right. So what is this, and is all fat bad for you? On the left-hand side of this, you can see a lot of problems with an individual, a cartoon individual, and the complications of obesity that one typically diabetes, sleep apnea, hypertension, cardiovascular disease. And so the question arises, what do we know about actual adipose biology, and how does it affect all these different disease states? On the right side is a cutout of a idealized human body, showing you all the different places where there are different anatomical, what we refer to as depots, where adipose tissue accumulates. And it's important to realize that we're going to use the terms adipose tissue and fat as somewhat interchangeable phrases. We have a large body of fat or adipose tissue that underlies the skin and covers our entire bodies. This is the so-called subcutaneous fat, and stretches all the way from the tip of our head down to our toes. There's also another broad area of fat referred to as visceral fat that is that lines and surrounds many of our internal organs, and in some cases serves a protective function, some cases somewhat of a shock absorber type of function. But it turns out that it is this visceral fat that is the type of adipose tissue that is causing us most of the problems with human health. So is there anything good that fat does for us? So I'm going to give you 5 good things about fat. Usually we're thinking of things that aren't so great, but I'm going to give you good things. 1, this is where you're going to store your energy. This is where you're going to put all of the excess calories such that you can sustain yourself in times when you cannot eat. For example, in the middle of the night when you're sleeping and your body needs energy, where is it going to get that reserve? Because clearly we have to keep maintaining body functions during that time. What we need to know is that your adipose tissue is the major site where all of the body's energy reserves are kept. And that's incredibly important. For example, when you're going to have a baby, you need to provide nutrients to the growing baby, and your adipose tissue serves as that energy reserve depot. Secondly, let's talk about fat underneath your skin, the subcutaneous fat. It's a physical layer between the skin, what we call the dermal cells, and the underlying smooth muscle cells. So we have this layer of fat underneath your skin that coats your entire body. And like oil in your car cylinder, your greasy fat tissue lubricates the system and allows flexibility. Imagine if the skin were more or less physically and hardwired connected to the muscles. Your ability to stretch and twist would be much more greatly reduced. And so this layer of adipose tissue is thought to be an evolutionary development that allows for improved motion and movement. At a little bit more of the molecular level, fat tissue secretes a large number of hormones. We now know of over 100 different hormones and proteins that the adipose tissue secretes that influences body functions, like influences eating behavior, insulin action, and even things like how bones are formed and how the muscles work. We all are aware, growing up and living in Minnesota, that fat under the skin helps you stay warm when you go outside into the cold weather. There's an inductive process called thermogenesis by which the fat underneath your skin actually burns lipids and converts that lipid energy into heat. And that's one of our body's primary ways of staying warm when we're outside. And lastly, fat actually protects us from bacterial and viral infections. And it does so by realizing that adipose tissue has a large number of immune cells in the tissue, and that these immune cells are positioned there all over the body to fight incoming attacks. As we developed through human evolution, our entire body was likely and many times nicked and cut and abrased, and we had to fight off infections. And having a layer of adipose tissue that had immune cells in it was incredibly protective for us. So there are a lot of good things that fat does. On the other flip side, there are things that it's not so good that fat does. Excessive fat around the internal organs is linked to a number of metabolic diseases like type 2 diabetes and cardiovascular disease. The excess fat around the internal organs is linked to certain cancers, including breast cancer, ovarian cancer, and particularly pancreatic cancer. In general, the more you become obese, the shorter you live. And in general, in the entire animal kingdom, those organisms that store large amounts of fat and adipose tissue tend to live shorter lives than animals that are very lean. And in fact, there's an entire society of humans who believe that this is so important that they eat very little food in order to restrict the amount of fat tissue they have. This is the so-called caloric restriction society. And these individuals are hopeful that they'll be able to live longer lives by being very thin. Now, on the other side, we know that excess adipose tissue limits your physical activity and reduces a person's ability to do simple things like walking and running and playing. And so quality of life issues come into play for those individuals who are grossly obese. And then lastly, for a number of factors, some direct and some indirect, socioeconomics comes into play with obesity. And obesity, people who are obese are known to earn less than lean people do. And so there are a large number of personal, metabolic, molecular things that go on with having obesity. Now, today, what we're going to do is to focus around the first one of these, how obesity around the internal organs is linked to metabolic diseases like type 2 diabetes, in the amazing new series of anti-obesity drugs that are hitting the market.
Well, thank you, Dave. So before we talk about these drugs, let's talk about diabetes, because diabetes very much relates to obesity. Now, just generally speaking, diabetes is a type of disease which is marked by high blood sugar levels. And this is either due to not making enough insulin, or the insulin that you make doesn't work, and we call that insulin resistance. So I'd like to talk a little bit about what is diabetes, and then we'll talk about its treatment and its relation to obesity. So you might have heard of type 1 diabetes. This is the diabetes that's actually due to not making insulin, and it only represents about 5 to 10% of cases in adults. The more common type of diabetes, especially when you hear of an adult saying they have diabetes, tends to be type 2 diabetes, and this represents 90 to 95% of cases in adults. Type 1 diabetes is due to the pancreas not making insulin. The pancreas is just basically dying out. And this is often due to autoimmunity, where your body attacks the pancreas and the pancreas just stops making insulin. And it's most commonly seen in children. So when you hear of somebody who has diabetes when they're a child, it tends to be type 1. In contrast, type 2 diabetes, which is the more common type of diabetes in adults, is that either that they don't make enough or there's insulin resistance. And this is the insulin resistance is the more common reason. And it's usually the result of lifestyle factors, and obesity has been well known to be associated with insulin resistance and therefore diabetes. And so this is where the obesity plays a role. Obesity leads to insulin resistance. The insulin you make doesn't work well, therefore your sugars go up and you develop type 2 diabetes. Well, let's talk a little bit more about type 2 diabetes. What happens is that when you eat, your body takes the sugar that you eat and breaks it down to simple sugar called glucose that gets absorbed into your blood. And then what happens is the glucose enters your blood, and then it kind of floats through the system, and your pancreas sees the glucose. When your pancreas sees glucose, it will make insulin. And the role of the insulin is to basically push the glucose where it needs to go into the different parts of your body. If you don't make enough insulin, your sugars will go up. And likewise, if the insulin that you make is insufficient, that's when you have insulin resistance, your sugar goes up. So that's kind of how type 2 diabetes works. What we know is that just as obesity has been increasing in the country, so has the rate of diabetes. And this is the rate of the prevalence, meaning how common diabetes is in the United States. What we have here is basically sort of number per 100 adults, so you can think about as a percent. And if you look at non-Hispanic white adults, the rates for diabetes is about 10%. But when you're looking at Black, Asian, or Hispanic, the rates can be quite high, anywhere from 20 to 25%. How do we treat especially type 2 diabetes, which is the focus of our talk today? The first one is, of course, always lifestyle changes. Eat healthy, eat less, exercise. The second level would be medications, and the medications would be either to reduce the insulin resistance, reduce weight, or potentially insulin. And then the last level, which is the most intense level, would be bariatric surgery. Bariatric surgery often makes people lose quite a bit of weight. They lose the fat, they become more insulin sensitive, the diabetes goes away. But obviously, this is quite significant. In terms of the medications to treat diabetes, the most common ones are metformin, what we call SGLT2 inhibitors, the GLP-1 agonists, sulfonylureas, and insulin. Sulfonylureas and insulin, basically sulfonylureas makes your pancreas secrete more insulin. Insulin, you give insulin. But these are sort of at more, we're not going to talk about these today. We're going to talk about primarily SGLT2 inhibitors, and of course, the very exciting medications, the GLP-1 agonists. Metformin is actually considered the first line treatment. So when somebody has diabetes, we always say diet and lifestyle changes, and then metformin. After metformin, we generally recommend either an SGLT2 inhibitor or GLP-1 agonist. You can see that in terms of SGLT2 inhibitors, they do cause a little bit of weight loss, and they also have some cardiovascular benefits as well as reducing the risk for heart failure. So let's just talk briefly about SGLT2 inhibitors. You might have heard of them. An example would be Jardiance, Farxiga, or Invokana. The way they work is that you have a protein in your body, in your kidneys actually. And so when your kidneys will naturally excrete sugar, right? So you will lose sugar in your urine. And what your body does is through this protein, reabsorb that sugar. And in fact, you actually reabsorb 90% of the sugar that sort of flows through the kidney. What the SGLT2 inhibitor does is it blocks that protein. And essentially what ends up happening is that you pee out your sugar. And because you have high urine glucose output, you're losing all the sugar, you're not reabsorbing it. You do see mild weight loss, about 1 to 3 kilograms, which is about what, 2 to 5 pounds, 2 to 6 pounds. And because there's so much sugar coming out in your urine, there's an increased risk for urinary tract infection and yeast infection. Of course, you also see improvements in blood sugar because you're losing all this sugar in the urine. And interestingly enough, there's actually a reduction in heart failure, and it actually helps preserve the kidneys. And that's sort of still under why this actually works. But certainly they work, and they're readily available. Now, of course, the more exciting medication that is all the rage are called the GLP-1 receptor agonists. And what they do is they actually cause weight change, quite a bit of weight change. And they also have some cardiovascular benefits as well. I will have Dave talk about the science of these GLP-1 agonists.
All right, thank you. So GLP-1, exciting topic. Science Magazine, the foremost scientific publication in the world in 2023, identified an entire class of new drugs that mimic GLP-1 action as the science breakthrough of the year. And subtitled this that obesity meets its match. So how does it do it? And so in order to explain this, I'm going to have to introduce three things. The first thing I'm going to talk about is a protein. It's a small peptide. It is abbreviated GLP and GLP-1, and it's an amazing hormone, and it is remarkably made in the gut, in your stomach, and secreted then into the bloodstream after you eat a meal. And GLP-1, though, circulates through the bloodstream, finds its way to the hypothalamus in the brain, and the hypothalamus is an integrating center in your brain, and it affects your hunger centers, and it causes you to feel full and reduces the urge to eat. And so this is the body's way of somewhat controlling how much food you consume, because as soon as you eat a meal, GLP-1 is secreted, circulates to the brain, and in principle reduces the urge to keep eating. The problem with this is that GLP-1 stays in your bloodstream for only a few minutes, and therefore you have to constantly be producing it in order to get any real beneficial effect. The second piece of this GLP-1 system is a protein in the brain called the GLP-1 receptor. It's another protein that actually binds to GLP-1, and it's the key feature that signals to stop eating. And so this GLP-1 receptor is in the hypothalamus, and it captures the circulating GLP-1. It's called the GLP-1R for receptor. And the last player in this is not a native protein, but it's a man-made look-alike molecule that is similar to GLP-1, and it has the same kind of an effect as GLP-1 does, and therefore it's called an agonist. So we're kind of familiar with the concept of antagonists. Antagonists work against us. Agonists are another set of similarly themed molecules, except they work in favor of us, and they GLP-1 agonists are look-alike molecules because they act just like GLP-1, but they can be given in higher levels, and remarkably, because of how they're engineered at the molecular level, they can last in your bloodstream for over a week. So that's the interesting and really transformative process here. So whereas native GLP-1 will be made by the gut, but is in your bloodstream for only a short amount of time, the drug that you will take, the medicine that you will take, the GLP-1 receptor agonist, can stay in your bloodstream for long periods of time. Even when you're sleeping or when you're exercising and you're not eating, that GLP-1 is still present in your system. So the concept here is this GLP-1 receptor agonist is going to reduce hunger and food consumption 24 hours a day, 7 days a week, and that you would take an injection of these drugs once a week to replenish that agonist. And this would overall reduce food consumption. If you reduce food consumption, this is eventually going to drive the use of stored energy from fat, and that consuming of your fat will lead to weight loss. And clinically, that's our observation, that GLP-1 receptor agonists reduce hunger, reduce adiposity, and over a period of time, it's going to lead to weight loss. So let's look a little more closely now at the GLP-1 drugs that we have in service. Lisa?
All right. Well, thank you, Dave. So let's talk about the GLP-1 drugs. There are 3 that are currently approved for weight loss by the FDA, and there are 3 that are there's 3 among others which are approved for diabetes treatment, for treatment of high blood sugar. So what happens for diabetes is they treat blood sugars and they help with weight loss. Obviously, if somebody doesn't have diabetes, the primary effect is just weight loss. The 3 that are approved for weight loss are one called Victoza, that's once a week. One is called Wegovy, and here's a picture that you see here. It's actually the same drug as Ozempic. It's just a little bit different in terms of dosage. And then there's one called Zepbound, which is also the same as Mounjaro, and this is tirzepatide. So Wegovy and Ozempic are the same. That's semaglutide. It's a once weekly GLP-1 agonist, and then Zepbound and Mounjaro is a combination of actually 2, GLP and GIP, which is also a once weekly drug. And this is what Zepbound. So Victoza, Wegovy, and Zepbound are all FDA approved, and you can buy this from your pharmacy with a doctor's prescription. So they're very popular. So it was featured in the New York Times that Oprah is that she's on a weight loss drug and is done with shaming. I have no idea what she's on, but presumably that this is semaglutide. But again, I don't know. But you can read this New York Times article, and she feels like it has been a really important part of her journey in weight loss. So liraglutide, let's talk about the evidence, the scientific evidence for weight loss. So liraglutide is also known as Victoza. You have to take it every day. And what you see here is different types of studies, right? In people with diabetes, without diabetes, pre-diabetes. And what you can see is that when you look at liraglutide, which you take every day, you have anywhere from a 6 to 8% weight loss. Now, just naturally being in a study will make people lose weight. And you can see in the placebo group, meaning that they did not get the active drug, there was anywhere from 0.2 to 3% weight loss. So just being in a study can make you lose a little bit of weight. Being in the study and on liraglutide daily, you lose about 6 to 8%. So this is semaglutide, otherwise known as Wegovy, also for if you have diabetes as Ozempic, and this causes a lot of weight loss. What we see here on the bottom is people and the time that they've been on the study, and you can see there are up to 68 weeks. What you have here on the y-axis is the change from baseline, meaning how much weight they've lost. Again, if you were on the placebo drug, meaning that you weren't on anything, it was just like a dummy drug, you lose maybe about 2 to 3% just being in the study. But if you're on semaglutide, you can see here, there's significant weight loss. By a year, 52 weeks, there's 15% weight loss. And when they extended it out to 68, it persists. So being on 1 shot a week of semaglutide, you can lose up to 15% of your body weight. This is exciting. This has been transformative. As I mentioned, there's another drug, tirzepatide, which also has been approved, also known as Zepbound. And this shows the weight change of tirzepatide. This is at 72 weeks, so a little more than a year. You can see this is the dose of tirzepatide at 5, 10, 15. Again, there's the placebo where they lost 3%. And what you can, the take-home message here is on tirzepatide 15, you lose about 20% of your body weight. So really the take-home message is that these drugs have been absolutely transformative. Victoza, which was the earliest GLP-1 drug, once a day, 68%. Semaglutide, once a week, 15%. Zepbound or tirzepatide, the newest kid on the block that's FDA approved, 20% weight loss. And now there's a lot of excitement of can there be more drugs, more possibilities? But again, this is what is currently available on the market. What are some side effects? Well, of course, there's side effects. First of all, there's a risk for pancreatitis. There's a risk for frozen stomach because it reduces how well the food goes through your stomach. There's a potential risk for pancreatic cancer. There's a potential risk for enlargement of certain cells in your thyroid that are precursors to a type of thyroid cancer. Of course, there's reduced appetite. interestingly reduce cravings. People have said that they're not interested in alcohol, drinking alcohol. Can also affect mood. People don't have the best mood. And most importantly, they can be extremely expensive. And in fact, it's very, very common for insurance to deny these medications, particularly for weight loss. They tend to approve them if you have diabetes, but if you're on them for weight loss, a lot of insurance deny them. Needless to say, they're extremely popular, extremely profit-making, and Novo Nordisk, which makes semaglutide, otherwise known as Ozempic or Wegovy, is now worth more than Denmark, just because of the popularity of these drugs. Now, what's interesting is what happens if you stop. And so this was a study that was done with the semaglutide. And you can see here, again, the time in the study. And these people were on the drug. And at 20 weeks, part of them switched to placebo, meaning that they went from active drug to the placebo drug, and they didn't know that. And half of them sort of continued on. And what they found is that, let's say by 20 weeks, of course, people lost weight. They lost about 10%. When you switch to placebo, they started gaining the weight back. So they went from 10% to about 6% weight loss by 68 weeks, whereas those who continued the drug continued to lose weight. And so it's estimated that when you stop this drug, you gain anywhere from 20 to 40% back. So really, when you're on these drugs, to keep the weight off, you sort of have to stay on these drugs. And that, of course, is very concerning to many people. I mean, you don't really want to be on something for the rest of your life. And plus, these drugs have only been around for 5 to 10 years. We don't know what happens when you're on them for 10, 20, 30, 40 years. So that's also an area of concern. What else can you do? Well, of course, people say to exercise. That's good. Exercise is great. But exercise has not really clearly reduced weight. In fact, it's shown that it helps with your metabolism, but just exercise by itself does not clearly cause weight loss. Of course, there's many benefits to exercise. It improves blood sugar, makes you feel better, makes your mood better. But again, not typically associated with weight loss. It can keep it off, but in terms of actual loss, exercise doesn't really do much. What is the recommendations for exercise? At least 150 minutes or more of moderate intensity exercise, typically walking per week. So this is about 30 minutes, 5 days a week. Or if you can, 75 minutes of more of vigorous exercise per week. So either or. And this is typically like running or a very, very brisk walk. It's also good to do strength training and flexibility training 2 to 3 times per week. And of course, it's also helpful to reduce sedentary time. For all of those who are sitting, by interrupting the sitting and walking around every 30 minutes, that's also considered activity. So as a general rule, exercise is good for you. The benefits are beyond just weight. It's just good for you in general. And these are the recommendations by the major organizations. So one thing I just want to point out is that we think that part of the reason why people are gaining weight is that because food is everywhere. And if you think about it, people used to be hunter-gatherers. You ate what you killed. You were a hunter, right? And so for about 2 million years ago to 10,000 BC, that was what humans did. Starting at about 15,000 BC, they started to domesticate animals. And by 10,000 BC, they had permanent agricultural communities, meaning that food being readily available has actually been a relatively recent phenomenon. Because food is now readily available, you can eat all the time, constant eating is actually normal. And one of my colleagues, Dr. Pennock from the Salk Institute, gave 150 people a mobile food app. They had to take pictures of everything they ate for 3 weeks. And each event is a black dot called an eating occasion. And you can see that there's more black dots around 8 a.m., more black dots around noon, maybe more around 6. But what you can see is that black dots are everywhere, even from midnight to 6 a.m. And what he found is that when you look at the eating window, the first time you ate versus the last time, about 50% of people ate more than 15 hours, and that they only stop eating when they're asleep. And so really, because food is everywhere, it's actually pretty common to eat all the time. Now, there's a very new hot trend called time-restricted eating or intermittent fasting. And so one option could be that rather than eat over 15 hours, why don't you restrict it to 8 hours? And this was a study that we had done here at the University of Minnesota. We had some people restrict to 8 hours. Some people, they just did their usual habits. Everybody had to track their food intake, and this was for 12 weeks. During the 8 hours, they can eat whatever they want. Outside, they would only drink water and take medications. And then we looked at their body composition. What we found is that with time-restricted eating, they lost about 7 pounds compared to the control group. Again, you always lose a little bit in the control. So this is about 2 pounds. Here they lost 7 pounds. And that when you look at their body composition, they lost lean mass, fat mass, and some belly fat. And so the idea is that if you eat only over 8 hours, when you're normally used to eating 15, and during that time you eat what you want, outside you just take water and medications, you can potentially lose up to 7 pounds over the course of 12 weeks. Of course, this is only 12 weeks. We don't know about the long-term effects, but this is an interesting idea that maybe eating all the time is not a good thing, and maybe we should shorten our eating window as an opportunity. So I will have Dave now sum up our talk.
So the breakthroughs of the year have given us this idea that we now have a remarkable set of drugs that will reduce hunger and body weight. And the loss of the weight is going to apparently reverse many of the effects of obesity, like type 2 diabetes. Similarly, this may be really effective for reducing cardiovascular disease. It's unclear if people need to stay on these drugs for a lifetime, that if changes in lifestyle occur, for example, time-restricted eating, or just simply reducing food consumption, you may not need to be on them for long. And these drugs are now being tested for other compulsive disorders, such as drug addiction and alcohol consumption, because the same kinds of processes that go into that kind of habitual activity is what people who overeat exhibit, and the same hypothalamic centers that work in drug addiction and alcohol consumption work in controlling our hunger. So there are new opportunities in the future, and there's a lot of exciting science and medicine that's coming to us over the next few years. So we want to thank you for giving us this opportunity to talk today, giving us an opportunity to answer any questions and to see if we can clear up anything and provide any insight. So we look forward to hearing your questions.
All right. Wow. Thank you very much. This is such a hot topic today. I did not even know that there was a society called the Caloric Restriction Society. Fascinating. Okay. So I do have one quick question about one of your graphs. You showed early on in your presentation a graph with the rates of type 2 diabetes per 100 adults based on white, Asian, Hispanic, etc. Was that the percent of all adults or the percentage of obese adults who develop type 2 diabetes?
I have to look at that. Should we pull it up? Can we do that?
Yeah.
I can go back faster this way than I can do this.
Oh, that one. No, it's per 100 adults age 20 and older. So it's all adults.
All adults, 10% for non-Hispanic whites. Okay, thank you very much for that. Can you address the definition of pre-diabetes? I have been told that there is no such thing, but I've heard the term a lot.
So pre-diabetes is, okay, so to have diabetes has very strict criteria. Number one, hemoglobin A1C greater than 6.5, or fasting glucose greater than 126, or any sugars greater than 200. But then these have to be repeated twice, meaning that if you just had a hemoglobin A1C of 6.6 and then you recheck and it goes away, then that's not diabetes. So there has to be a persistence. So when you meet that criteria, you're considered diabetes. Now there's also normal. Normal is generally fasting glucose less than 100, hemoglobin A1C, which is the 3-month measure of glucose, 5.6 or something like that. So that's considered normal. So anything in between is considered sort of pre-diabetes. So you're not normal, but you don't yet meet the criteria for diabetes. That being said, it doesn't mean that, you're not on your road. Certainly people who have pre-diabetes have higher risk for developing diabetes. And so that should be considered sort of a warning sign or signal to maybe make changes to the diet, maybe try losing 5 to 10 pounds and try to stave off that progression. It's well known that people with pre-diabetes can revert back to normal, but certainly, you do have to be aware and try to work at it.
Okay, so what about people who eat for emotional reasons and not out of hunger? Does this drug show any effect for those folks?
We think so. That being said, that these drugs can increase the risk for depression and suicidal ideation and can worsen their mood. So there is a concern about that. So, but certainly what it does is it reduces your appetite, right? But there's a lot more that goes into eating than hunger. And that, of course, is a very complex question.
Yeah, it is. So you also mentioned that there is interest in seeing if these drugs work for other addictive behaviors. Have there been any studies or any information published yet on initial observations about this?
So initial observations are very encouraging, and there are a number of clinical trials currently going on at the National Institutes of Health and at medical centers around the U.S. supported by the National Institutes of Health. Small anecdotal information is sneaking out that it suggests that they are similarly efficacious for reducing those other kinds of binge disorders. But it's very early in the game, and we're just going to be watching that. But it does present an exciting opportunity that this class of molecules may be more widely useful than we anticipated.
That's amazing to me. That is truly life-changing if there's a broad use for these. Okay, let's see. Another question. Can type 2 diabetes be attributed in some proportion to family genetics or heredity?
Yes. Or do you want to comment on that?
Yes. In general, yes. A small fraction of individuals who have type 2 diabetes have molecular defects, for example, in insulin itself, or in the insulin receptor, or in any number of different proteins involved in facilitating sugar transport around your body. But again, those percentages have not changed over thousands of years. And so the dramatic increase we see in type 2 diabetes that's occurred since 1960 really are related to more environmental factors. And again, it is food consumption and obesity that seems to be the driver. But to 5% of all the cases.
One thing that we commonly see in the clinical medicine is that they say the highest risk for type 2 diabetes is having an identical twin with type 2 diabetes. And interestingly, the genetic for type 2 diabetes is stronger than for type 1. So yes, I agree. There's a very strong genetic component to type 2 diabetes.
Oh, interesting. Interesting. Okay. So we don't know, you said we don't know too much about the long-term use of these drugs and what side effects or how, and I hesitate to use the word healthy, but whether these are deleterious over the long haul to someone's health. Have they been studied for just how long? What is the longest amount of time that studies have been reported? I'm not asking this right. You know what I mean?
I do. So the drug, the GLP-1 class, has been around probably for almost 20 years, but it's been primarily used for diabetes, and is primarily, this is that Victoza I had mentioned, it was once a day. It was primarily used for blood sugar control, and there was very modest weight loss. And it didn't do much, and there wasn't a lot of interest because not much happened. Actually, the very first one was called exenatide or Byetta, which you had to take twice a day. The new stuff it's much more stronger, it's much more potent, much more profound weight loss. So this is a whole different ballgame in terms of effects on side effects. So we don't know. So I would say, but the original class probably has been around for, I don't know, 20, 30 years, but not to this level of potency or effects.
Okay. Can you take these drugs, these GLP-1 receptor agonists, along with other diabetes drugs like metformin? Any contraindications to that?
Yes, if you take them with metformin, you do. So,
You do, yeah.
yeah.
So actually, again, the first line of treatment is always metformin, and then we would add these drugs on top. So we would add the SGLT2 inhibitor on top, or we would add the GLP-1s on top. And in fact, we have people who have diabetes treated with insulin, and we put them on these GLP-1s, and their insulin requirements significantly reduce because they lose weight, they become more insulin sensitive, they don't need as much insulin. So certainly you can add this onto current treatment for diabetes as long as there isn't a contraindication to it.
Okay. Can you describe the mechanism by which excessive weight causes type 2 diabetes?
You want to do that? Or
Yeah.
Go for it.
Yeah. First of all, type 2 diabetes is not a single gene defect. It is, we refer to as a syndrome. And so there are a large number of different effects that happen. But at the level of the adipose tissue, one of the most profound observations is that when an individual becomes obese, their fat tissue accumulates immune cells. And those immune cells produce a low-grade chronic inflammation in the adipose tissue. And those immune cells secrete different factors that biochemically block insulin action. And since insulin stimulates sugar uptake, if you block insulin action, that implies that you will end up having blood sugar elevated for long periods of time that we refer to broadly as insulin resistance. So the connection between obesity and insulin resistance is generally believed to be through inflammation and the presence of immune cells in your fat tissues.
And then those immune cells attack the beta pancreatic cell?
The immune cells actually secrete things that work at the level of the adipocyte or the liver or muscle, or in some cases, the pancreas. And so we end up with a situation in which the immune inflammatory factors are blocking insulin action. Many cases, people who have type 2 diabetes actually have higher than normal levels of insulin. It's because the pancreas tries to compensate for not working very well and generates supraphysiological levels of insulin. And so it's not so much the inability to make insulin, but you can't respond to it.
Interesting. Okay. So does insulin resistance make you hungry, for example, because your cells aren't getting the glucose that they need?
So indirectly, insulin resistance that results in increased adiposity, increased weight gain, induces the increased expression of a particular protein made by fat cells that circulates and binds again in the brain and controls your eating behavior. And so not directly insulin per se affecting hunger, but it is indirectly, you do have influences through a number of different biochemical processes that eventually do center on that that mood and emotional center in the brain called the hypothalamus.
Mm-hmm. How common are these side effects that you mentioned, including mood? Which are the most common and how prevalent are they?
It kind of varies. I would say that the most common side effect would be sort of GI upset, and I think probably the most common one is the loss of appetite. And then the second most common would probably be GI upset. It's hard to say. I mean, it's hard to say if it's the drug effect or it's the, it's just life effect. It's a little bit hard to separate out. And it certainly everybody's a little bit different, right? We have people, you give the medications, they don't respond at all. We give people and they give the medications and they lose 100 pounds. So that's actually another very interesting area of research. Who responds how, when, and why, with what side effects? So that's an active area of investigation.
Do we have any ideas, or what is a hypothesis there on why some respond and some don't?
It's a great question. It's really unclear why some individuals on Ozempic or Wegovy respond quickly, they lose weight, and other individuals simply don't. There are a number of factors that control this balance of weight and fat cell function. And one of the general thoughts is that possibly that some of these molecules may have effects in other cell types, not just the brain. We know that their receptors are present on fat cells and other cells, for example, and it may be those other sites of action that might be affecting this so-called Wegovy or Ozempic resistance that a small number of a small fraction of people seem to exhibit.
Okay. So is this Zep-bound, this new drug, is that also a once a week administration, and is it an injectable or a pill?
It's an injectable. It is one molecule that can act on two sites. It can act on the GLP-1 as similar to semaglutide, and it also acts on GIP. So it's one molecule that has two areas that it acts, and therefore it has a greater effect on weight loss than just the GLP-1 alone. And it's a once a week injection.
Which was the medication that is a pill?
There is an oral version of semaglutide or Wegovy, but that one you have to take every day. The issue with it, it does work. It doesn't work as well because, you know, this is a protein. And when you eat a protein, it gets dissolved in your stomach. So it's specially encapsulated so that it gets absorbed. But when you compare the pill version to the shot version is much more efficacious.
Yes, that makes sense. Although some people are so averse to injections. Yeah. Okay. Does GLP-1 drugs, do they affect kidney function?
There's some thought that, you know, right now GLP-1s are been shown to be efficacious in many things. It's been shown to be efficacious in reducing heart failure with preserved ejection fraction. There's some thought that it might improve kidney function. Certainly, it doesn't affect kidney function and in fact might improve it. But we don't know. It's just almost like they're thinking of any and all excuses to try it and see the benefit. In fact, Dr. Bernlohr and I were just looking at an article that shows potentially a GLP-1 might help with movement disorders in Parkinson's. So there's a lot that still remains unknown. As far as we know, it doesn't hurt kidney function, and in fact, it might improve it.
So with all of this wonderful news about these particular drugs, do you, this is a real hypothetical question here, do you foresee that insurance companies will jump on board and begin paying for this in non-diabetic populations? Because the other health issues caused by obesity are so dramatic that paying for the drug is perhaps cheaper.
Well, as you know, they can be extremely, extremely expensive.
Right.
And I think the issue is, what is the long-term effect, right? I mean, they might work for a year or two and people do great. You stop it, you gain the weight back. What happens? I mean, do they really want to commit to paying this drug for the rest of somebody's life? I think that is a difficult thing. I mean, certainly when you do bariatric surgery, there's the expense of the surgery. And then after that, you know, you're kind of done. I think there was a head-to-head comparison of bariatric surgery benefits versus GLP-1s. And it's thought that over the long term, bariatric surgery had a better cost to price ratio compared to these GLP-1s. Certainly they cannot be as expensive as they are right now. If they get to be much cheaper, Maybe. I would say that there's a caveat is if you're going to be on a drug for 10, 20, 30, 40, 50 years, we do very much worry about side effects and we don't know what they are. So we can't just say that they're necessarily the answer to everything.
Is it hypothesized that the reason people gain weight again when they go off these drugs is just because they didn't make the lifestyle changes permanent after stopping the drug?
So I think in most cases, individuals who gain the weight back do so because they begin to consume, again, greater and greater levels of food. So it's a consumption issue. I think if people could manage lifestyles and manage food consumption, the ability to go off of the drug successfully would be greatly enhanced. But humans are chronically known for not doing what they're supposed to do. And since food in general affects our pleasure centers and food is hedonic, there's a lot of drive to consume food.
That is true. I'm trying not to snack on some chocolate chips while we talk during this presentation. So thank you for that. Does anyone know how this drug might be working in Parkinson's?
The study just got published and it's very preliminary. Yeah.
Yeah, right. Okay.
An area for future discovery, but it just got announced.
Do you have any comment on the ethics of prescribing these drugs to obese individuals and not those with diabetes type 2? Because apparently there's a shortage and those with diabetes are unable sometimes to get these drugs. Is that because of cost or just because there are not enough of them? And the ethics question, all wrapped into one.
Yeah, it is. It's obviously something that we think about a lot. Access to medicines, cost of medicines, availability to disenfranchised people, those without insurance, are all really important. And making potentially impactful drugs available to people is something that I think all of us have goals for. Those people like myself who have been working in the area of obesity are excited because we're finally seeing the edges of some kind of a treatment that seems to have an impact not only just on the cosmetics of obesity, but also on the health consequences. So being able to translate that to all people seems like it should be a goal, provided that they're safe, provided they're efficacious, provided that there aren't side effects that are unknown and unanticipated. And there could be exciting reasons to consider this drugs and the next generation drugs that follow it for a large number of different kinds of clinical problems, and making sure that we're aware of how this impacts different groups of people with different genetic and metabolic backgrounds is something that I think you're going to see more and more of over the course of the next decades.
Certainly the priority is getting this drug to people with diabetes. And if you look at insurance companies, they will pay for these drugs in people with diabetes. The next level then would be people who are interested in weight loss, but may not have that as many complications. And that therefore that would be sort of the next tier. But I would argue that, these drugs should go to the people who need them the most. And this would be people with obesity and diabetes. Right now, it's a production problem. They can't make it fast enough. And, there's a huge demand. So that's a little bit of the reason for the shortage.
What about the compounded versions? Can you speak to that? Are they as effective? Are they safe?
No, we don't recommend the compounded version.
Why is that?
I would say a big part is quality control. You don't know who's making it. You don't know whether the product is the original product. If you're going to put something into you, you want to make sure you come from a reputable source with, quality control. And so I would say there's a real concern about the quality of these compounded medications. Because right now, if you want the semaglutide, you have to get it from Novo Nordisk. If you want the tirzepatide, you get it from Eli Lilly. There's all these factors in place on how they make it, right? With the compounding, who knows? And so I think there's a real safety issue. So if it wasn't for that, yes, it's the same drug. But I think there's a lot more than just the drug itself.
Okay, thank you. Does the weight loss prompted by these drugs, is it the same type of weight loss that you would experience if you're on a diet, for example? What I'm really getting at is, do you lose muscle mass more than fat tissue with these drugs?
Since the drugs are affecting our hunger centers, and you will reduce food intake, you end up going into something that we broadly refer to as negative energy balance. And this implies that the stored energy in your fat is what's going to be helping and fueling the body during the time when you're taking the drug. And this is what drives the weight loss. It's actually the utilization of adipose tissue. Now, we have these depots around the internal organs, and we have depots under the skin. So the question has been whether or not the weight loss drugs affect both areas similarly. Remarkably, there is dramatic effects on reducing adipose tissue that on the depots that surround the internal organs. It also affects the subcutaneous fat to a lesser extent, but the depots that seem to be more linked to the metabolic diseases like diabetes are more profoundly influenced. Having said that, there is something that's classically called Ozempic face or something along those lines, in which you lose the subcutaneous adipose tissue in your face and in your cheeks, and people end up with kind of a sunken face that is somewhat of a tell for taking the drugs.
Interesting. Okay. And I should have asked for you to also, if you could define the term compounded that I used earlier for some of our guests.
Well, compounded is generally you have the original drug, and then you mix it, and then you administer it. But usually it's done by pharmacies that are not, they're not the company. So you go to a compounding pharmacy and they sort of mix it up, custom made for you. But where they get the original product and what they mix it with, and then how can they ensure the purity of what they mix, it's kind of pharmacy to pharmacy dependent.
Thank you. Okay, back to that chart that we were talking about at the beginning of the Q&A session. It didn't seem to include any indigenous Native American population. Do you know if these drugs have been studied in that population? I know the chart was not about these drugs. The chart was just about obesity in general. So my question applies to both areas. Have the rates of obesity been studied in Native Americans, and are these drugs being studied to see if there's any different effects?
The rates of obesity and diabetes is quite high in Native Americans, extremely high. And so certainly they would benefit. With a lot of these randomized trials, they open it up, they ask people to volunteer, and it's up to people if they are interested. And, I would say that certainly when you look at the population who tends to volunteer for these studies, it tends to be primarily white, non-Hispanic white, and especially women. That seems to be a demographic that seems to be willing to participate in these studies. And so relatively speaking, although they try to be diverse and include people from different populations and diverse groups, sometimes they just don't want to be as part of a study, and that's understandable. And so if they're not going to be in the study, or there's less of them wanting to be in the study, there's less opportunity to see the effects.
Are there any trials currently going on at the U that are looking for participants?
I would recommend that they go to www.clinicaltrials.gov. Any study that's a clinical trial that has been IRB approved will be listed there, and that's probably the most up-to-date about what are active studies going on here at the university and beyond. Clinicaltrials.gov.
Thank you. That's a great reference. All right, one of our guests has said, wouldn't it be cheaper to give free gym memberships, lifestyle coaching, and nutritional support to people rather than these drugs?
So whether or not over the lifetime it would be cheaper, unknown, but we have since the early 1960s recommended lifestyle changes and exercise as a vehicle for really preventing and then combating obesity-linked diseases. And for a fraction of individuals who are able to do that, it works very well. But the overall wide observation in at least this country, as well as others in industrialized nations, is that people don't follow that, is that they tend to fall down, they binge exercise, they buy exercise equipment, and then by April, it tends to sit in the corner. And so it has more to do with compliance and the long-term benefits. Obviously, if we could do it, we would do it, but I think there's lots of opportunities here.
I would say generally the lifestyle changes are maybe 5 to 10%, maybe 15% weight loss at the most. Usually it's the scale of 5 to 10%. Here you have a drug that's once a week, 15% weight loss, 20% weight loss. So much easier. I think it's just easier for people to fit. You often hear that people they feel like they don't have the time to exercise, or they're injured and they're unable to exercise, etc. So really, I think compliance and the durability of lifestyle changes has been less than we would like, but certainly it's optimal. If you can do that, that would be best.
If only there were a magic pill for following all of those directions. They're hard to do. Are these new drugs being prescribed for those that are insulin resistant but not pre-diabetic?
I would say most people who are overweight or most people who are obese do have a component of insulin resistance. So certainly if you are overweight, and remember I showed you the obesity rate, it's much higher. There's insulin resistance there. But again, usually a lot of insurance will only pay for people with obesity and diabetes. But certainly obesity does relate to insulin resistance. Dave, do you want to comment on that?
No, I agree with them.
Is hypoglycemia a factor here in any of these disease processes?
I have not heard of that as a complication, that in terms of driving down your blood sugar so low that hypoglycemia becomes a clinical problem. I just don't think I've seen it reported that is something that clearly, because you do make measures of all those, if it was occurring, you would measure it and know about it. But I think I don't know about it. Lisa?
We haven't seen, if you're just on these drugs alone, you don't see hypoglycemia. So the metformin, the SGLT2, the GLP-1s, there's no real hypoglycemia associated with them. But if you're on these drugs and you're taking insulin, you're going to get hypoglycemia. If you're on these drugs and you're on a sulfonylurea, something that can cause hypoglycemia, you will get hypoglycemia. But just by themselves, they're not associated with it.
Okay. Another question, perhaps about genetics. Do you know why people of color have a higher prevalence of diabetes?
That's a complicated one. First, is there a genetic? Can we identify specific alleles in the human population that may predispose individuals to type 2? And are those genes more prevalent in the African American population? Again, it's very, very rare. It's a small percentage. I think again, lifestyle and environment factors seem to play a role. But the genetics of type 2 diabetes in different populations is extremely being studied right now all over to try to identify if there might be any factors that are large enough that they're causing differences in population studies.
There is a theory. And the theory is that, for example, as I had mentioned, the rates for diabetes and obesity is very high in the Native American population. And so, again, a lot of them were hunter-gatherers for quite some time. And so their body was used to retaining food. So when you ate something, their body would hold on to it. What you ate, you held on, kind of tided you over until you managed to get more food, and there you go. And when food is plentiful, well, their body likes to hold on to food because that's what they did. And it's now that you have lots of food, it holds on to a lot of it. And so it's easier for them to hold on to calories and retain it and as well as like a genetically evolved situation. So that's kind of the sort of the story behind potentially why, but it may have been related to how their body adapted to their, generations of lifestyle this way.
Do you have any recommendations for books or other media to help folks understand diabetes and the drugs used to treat it?
The American Diabetes Association has an outstanding website that you can easily Google that has a patient interface with a tremendous amount of information on lifestyle, on drugs currently available, on clinical trials. And it's a great resource for people who would like to do some more reading. So simply Google American Diabetes Association and it will direct you immediately right there.
Great resource. All right, you showed a very large increase in obesity since the 1980s. Do you have an opinion on how much of that increase is caused by the food source itself? For example, animals being fed growth hormones, trans fats, GMOs, or is it thought to be strictly related to the volume of food being consumed?
I think the thought is that there's a lot of sort of readily available, calorically dense, ultra-processed food. That's the primary reason for it. In terms of the details, whether it's, I think that needs to be laid out. But certainly, it's very easy to eat food that are cheap, affordable, readily available, high in calories. That's very different than what was originally, it originally was. So, lots of potato chips instead of the actual potato, that type of thing. So certainly it's how the availability and the type of food that's available now. Dave, you want to comment?
There's no unquestionably, just as a correlation, the expansion of the fast food industry and calorically dense foods and obesity are strongly positively correlated.
So this next question sort of feeds into that answer as well. Do you have statistics or facts that you can tell us about obesity being studied around household income levels? And is that maybe related to food deserts, the cost of healthy food, that sort of thing?
I mean, food deserts are real. There are environmental and regions where accessibility to various kinds of fruits and vegetables for people to consume is a major issue, particularly in urban centers and in some rural environments. The types of foods that are available and the socioeconomics of obesity have been studied for a number of years. Simply because there's unquestionably a correlation between socioeconomic status and obesity. And there are as many factors as you can possibly think of. They are listed as variables that could influence the process. Is there any one smoking gun? No, that we haven't been able to identify. Again, it's a complex syndrome as opposed to a single gene disorder.
Mm-hmm. Okay, one question back to intermittent fasting. Does this 8-hour window of eating matter as to which 8 hours you pick during the 24?
It's generally thought the earlier the window, the better the effect. That being said, if you do pick an 8-hour window, we generally say you try to stick to it so you don't switch it all the time. what we have found is when we ask people to stick to an 8-hour window, they actually do a 10-hour window. But it's just kind of the concept, right? You don't eat all the time. So I would say if you just go with that concept of not eating all the time, there's probably benefits to be had.
That is very interesting. Okay, are there any side effects reported on these drugs regarding mental function other than mood? You know, for example, any trouble with driving, any warnings people shouldn't drive or operate heavy machinery while on them?
Not that I'm aware of. Not that I'm aware of.
Okay. And who is the best provider to prescribe these kind of drugs? A primary care or a specialist such as you, Dr. Chow, an endocrinologist? What would you recommend?
Well, ideally, it should be under the support of a medical professional, right? And if it's a primary provider who understands what they're doing and they have experience and they're well versed in it, it would be them. That being said, these drugs are becoming increasingly popular and Weight Watchers is stepping into it. Costco is stepping into it. Some companies are stepping into it. And so there's a lot of sort of non-traditional, like primary providers or endocrinologists who are jumping into the fray to sort of prescribe it. I would say the most important thing is when you're on it, that you are monitored and that, you know, there should be an active discussion, whether this should be continued, cut back, etc. And so I think working with a medical professional who feels comfortable doing that would be best. What you don't want is to be put on the drug and say, you're great, see ya. Because I think there should be an active conversation to try to minimize it and, you know, be on the lowest possible dose if possible. But certainly there are many, many places jumping into the fray outside of the traditional medical structure.
When a patient is put on these drugs, are they also given instruction on other lifestyle changes like exercise or restrictive diet in any way, or just take the drug and watch the weight loss?
I would say if they're a responsible provider, they would recommend dietary and lifestyle changes. Whether or not people hear it and want to do it on top of it, that's a different story. But if you're a responsible provider, you should. Dave?
I agree completely. I think often you find that you are asked to increase your exercise or begin a moderate exercise program of simply walking in a combination with the drugs because they all can play a positive effect and potentially potentiate the outcomes.
So the placebo folks on these trials are also given the same instruction on lifestyle modification, I'm assuming?
Well, we find that just being in a study, people do lose a little bit of weight. The fact that they feel like they're in a study, they're monitored, they don't know if they're on the active drug or not, they do actually lose a little bit of weight, but it's modest. It's about maybe 1 to 3%.
So those people are probably exercising as well as the other side of the trial.
A proper placebo basically is they're doing everything the other group is doing, except they don't have the active intervention. So when you're on the different shots, you know, so they're given a thing, the pen looks like the pen that everybody else is using, except it's actually filled with salt water. So they don't know what they're on. And so, you know, they're sort of given the instructions. They do everything the same. It's just that they might be on that drug or not on the drug, and they don't know that.
What kind of monitoring do these patients need?
Ideally, the patient should be in a dialogue with their primary care physician or whomever is prescribing it, and that there's some kind of an active reporting and back and forth going on all the time, such that the patient and the provider and your physician are acutely aware of any side effects, any weight loss, any positive effects, and so that the patient is not out on their own, that this is monitored.
Is there blood, you know, does it involve blood work or just checking in and weighing?
Typically not. It's simply just on a weekly basis, it's simply checking in. However, your primary care physician will ask you to come in, for example, after 1 month or 3 months or sometime for a blood draw, for example, to see if your blood glucose decreases and if your hemoglobin A1C has declined, which would be a positive outcome.
And
Okay.
remember, if you're at diabetes and you're on these drugs, you do have the risk for hypoglycemia. And so there's an active probably participation to reduce the other medications, your insulin, what you used to be taking because you don't need so much. So that way, there's a lot more monitoring, especially if you have diabetes and on these drugs.
Mm-hmm. And so you had said earlier that there's roughly a 15 to 20% weight loss with these drugs over a long period of time. Is that weight loss enough to affect all of the positive health benefits, or do you need to continue to go lower than that?
Some individuals will have remarkable reduction in circulating glucose and A1C levels with even a less significant weight loss of even 5 to 10%. And it's somewhat variable from person to person. And that's why we do need to continual monitor. But some individuals can have remarkable reversals in a very short amount of time with less than full weight loss.
Mm-hmm.
Usually we like at least 5% weight loss. One of the hot topics in obesity research is who benefits what, who improves their blood sugar, who improves their weight, who improves their body composition, and they may not necessarily be the same people. But it's generally thought that the more weight you lose, the more benefits you get. So something is better than nothing.
Yes. Are other countries using these drugs for obesity as America is? I think the rate of obesity may be less in other countries. I don't know, but is the use in other countries as much as in America?
So actually what's going on in a lot of countries is that companies tend to sort of sell these drugs to America because America will pay full price. And it's an insurance issue. And so they try to reallocate to where they can make the most money. So a lot of other countries, they're not getting it in the volume that they are here in America. So they would love to have it, but there's actually relatively reallocation to America who's willing to pay more for the drug.
I'm going to ask this one next because I don't want to end on it. Has there been any reported mortality related to the use of these drugs?
Well, I mean, when you look at these studies, I mean, there's always mortality, right? You have to compare the mortality relative to placebo. It's thought to be actually beneficial with lower mortality, but certainly, have people been on these drugs and died? Yes. Would they have died due to the drug or outside of the drug? It's hard to say. But if you look at mortality, it's thought to maybe be beneficial. But again, keeping in mind that they're very, very new. So presumably that it will be less over time.
And I would presume that there has not been some large percentage, meaning, I don't know, 5% or less, somewhere in there, of people who become direly ill on these drugs, correct?
Not obvious, but I mean, again, there's the GI upset, there's the frozen stomach, there's the poor mood. I mean, there are things. Just like when you take any drug, there are issues, right?
What is the percent of those side effects, though? If you know, is it 1% or less who experience it, or 10%?
Okay, when you look at these studies, right, any side effect that gets reported is reported. And so if you look at anybody who reports any side effect, it's like, I don't know, 80 to 90%. But whether it's real and serious, that's like a different story, right? Because even on placebo, you can have side effects. So if I had to guess, this is just me guessing, I would say the serious side effects is probably 20 to 30%. But has anybody ever had any side effect related to drug, which may or may not be related, I'd probably say 80 to 90, like they feel funny, that's a side effect. I mean, it's hard to say.
Mm-hmm. Yeah. All right. Do we know if this class of drugs affects metabolism, or is it just the hunger cues?
Sorry, you have to repeat that?
Do you know if this class of drugs affects metabolism, or does it just affect the hunger cues?
So indirectly, it will affect the metabolism of the fat cells. Once you reduce your food intake, your body will go into a negative energy balance, which will promote the breakdown of fats in your fat cells. So metabolism will be increased due to that, due to the need for weight loss. So that does happen, yes.
Okay. And then we had a question about the trade names. I think you gave all trade names. Victoza, Wegovy, Zepbound, Ozempic, Trulicity, Mounjaro are all the trade names, correct?
Correct.
Okay.
Indicate, I'll speak for myself first. I have no financial interest or conflict of interest or connection to any of the companies that are producing any of the molecules we discussed today.
And neither do I. There's no conflict of interest.
Fantastic. Well, thank you. I want to remind our listeners that this presentation is being recorded and it will be available on our OLLI University of Minnesota YouTube channel, so that you can view the slides and hear the presentation again, and if you're curious. At this point, I don't have any additional questions for you. So we're almost out of time anyway. I think we'll wrap it up. Thank you so much for this presentation. We've had a number of positive comments and thank yous for all the information. People have learned a lot from you today. So I appreciate your time and your presentation. Please join us next week on April 25th for the next series in our class called The Post-Pandemic City: Space, Structures, and Design in a Post-Pandemic World with Professor Thomas Fisher. We will see you then and have a great day. Thank you. Bye.
Thank you.
Thank you,
Bye.
everybody. Bye now.